This question on the parabola is page 107 of your workbook. We started this one in class, and in this video I'm going to finish the question. We're asked to redraw the parabola in the given rectangle A, B, C, D, which is here. And then the second part of the question, we're asked to complete the logo by constructing tangents from point P to the circle K. So from P to this circle K. So firstly I'm going to finish the parabola. During class we identified some of the main parts of the parabola, like the axis, which is a line that splits the parabola in two. The point O is the vertex of the parabola, similar to an ellipse. Okay. We started out by dividing half of the total rectangle into equal parts. So we took the line AD and divided it into 1, 2, 3, 4, 5 equal parts. We drew a line at any angle from one of the ends of the line, marked off a suitable distance, 5 of them, with our compass, joined the last point to the end of the line, and then we used sliding set squares to draw lines from the other points back to the edge of the rectangle. We also divided the bottom half of the rectangle into 5 equal parts. If we divide this side into 5 equal parts, we must divide the bottom into 5 equal parts as well. The points that we found on this edge of the rectangle, which is parallel to the axis of the parabola, are connected back to the vertex, and that's indicated by the yellow lines. The lines on the side of the rectangle down at the bottom here are drawn parallel to the axis, indicated by the red lines. So that's an important element you must remember when constructing a parabola. The edge of the rectangle parallel to the axis is connected back to the vertex. The other edge, those points, we draw lines from them parallel to the axis. You can also see that we indexed points 1, 2, 3, 4, 5, and the point 5 is shared between this edge and that edge. So 1, 2, 3, 4, 5. The point 5 is the first point on the parabola, or the vertex of the rectangle. So to find other points on the curve of the parabola, we follow the line from point 4 on the bottom and point 4 on the side, and where they meet is a point on the parabola. We do the same with point 3, finds another point, point 2, another point, and from point 1 determines the last point. What I can now do is freehand draw in the curve of the parabola, and this takes a little bit of practice. It should be a smooth curve, so just a little tip on doing this: I would always draw the curve in as light as possible to begin with, and try and keep a smooth transition to the vertex. If you're happy with how that turns out, you can swap pencils to your 2H pencil, or darker if you wish, and just heavy in over that line again. So again, the curve needs to be smooth and transition nicely to the vertex. There should be no point on the vertex here. Please remember that I have highlighted these lines in red and yellow for visual purposes. During your exam, these red and yellow lines must be kept as construction lines, i.e. they must be very, very light. the curve of the parabola should be the only line that stands out in your drawing. Now we only have half a parabola here, so we must complete the second half. We could repeat this process on the left, do the same thing on the right, but there's a much quicker way that you should use, especially in an exam. And this technique is called axial symmetry. Axial symmetry is used to mirror the points from the left to the right. During your exam, you will be asked to complete an axial symmetry in short questions. So the next part of the video, I'm going to show you how to complete an axial symmetry. If you remember from the start of the video, I highlighted this center line as being the axis. And that's where the word axial comes from. Symmetry means, if you remember, everything on the left hand side is a mirror image of what's on the right, like a butterfly. So what we can do is, we can transfer these points through the axis of the parabola with a construction line perpendicular to the axis. I'm going to do that using sliding set squares. Obviously in an exam you can use your t-square. So I'm just aligning the top of my set square with this top edge to ensure I get a nice horizontal line. So from each point I'm drawing a construction line perpendicular to the axis over to the right hand side of the rectangle. For each point just making sure that all of these lines are parallel to each other. Point 5 here does not need to be transferred across as it's done already. So point C here is a point on the parabola, as is point O, which is the vertex. When you draw these lines perpendicular to the central axis, we need to use our compass to transfer the point from left to right. The distance from the axis to each point on the curve that you've already drawn will be the exact same distance from the axis to the points on the right hand side. Hence, the parabola is symmetrical. Axial symmetry means symmetrical about the axis. Everything on the left is the same as everything on the right hand side. Okay, so the final step, taking my compass, and I'm just going to set the tip of my compass to be as accurate as possible. Make sure before your exam that the tip of the graphite is in line with the tip of the point of your compass, and you can adjust it using the little thumb screws at either side. This will help you create more accurate circles and transform points more accurately. So the point of the compass goes on the axis. Set your compass to the distance from the axis to one of the points and just rotate your compass around to mark off that point on the other side of the parabola. I'm going to do this for each of the points down along the axis. For the last point here, I might just zoom in a small bit and just see it a little bit better. Okay, so the point of the compass goes on the axis. Set the distance to that point, and you can transfer it then to the right hand side of the rectangle. Now you have all the necessary points to draw in the other half of the parabola. So once again, I'm going to just attempt to draw in that curve nice and light to begin with. I might start at the top, I'll start at the bottom this time. So it's a little guideline to begin with, and I'm trying to curve it in nice and smooth to the vertex. I think that looks okay, so I'm going to come again now with my 2H pencil, or this is actually a HB pencil, which I find useful for the finish lines. It's personal preference, and I'm just going to heavy in over that curve. I'm trying to avoid having any points, or I'm trying to avoid creating vertices in the parabola. Okay, so there's our parabola complete. So again, we've divided up half of the rectangle to find the first set of points. When we found those points, we used a technique known as axial symmetry to transfer those points from one side to the other. In the exam, you can be asked to complete an axial symmetry as a short question separate to the parabola.